Everyone, let's talk about array. Array is a beautiful data structure. It is fixed in size, allocates similar type of elements. You can declare an array in two ways. So I'm declaring an integer array so that it is going to allocate only integer type of elements. And you can declare an array with fixed size. So I'm allocating size of an array as 5 so that this array is going to allow at max 5 elements. You can declare an array by assigning the values directly. So I am going to initialize the array with values 10, 20, 30, 40 and 50. If you closely see, in both the cases, array is fixed in size. It allocates at max 5 elements and it allows only integer type of elements because you declared an array of type integer. So let's see why it is fixed in size. Let's see the concept behind it. You have 5 elements in an array, right? So that each element of type integer in Java, integer element is going to occupy 4 bytes of memory. So there are 5 elements. So that 5 into 4, so there will be 20 bytes of memory block is allocated for this array. And this 20 bytes of memory block is divided into 5 slots. And each slot is uniquely identified by an identifier called as index, which is starting from 0 ending with n minus 1, because here array length is 5, so last index is going to be 4. And the starting address, let's assume the starting block address is going to be 2000, let's assume. Then the next slot address is going to be plus 4, so 2004. And next slot address is going to be starting with 2008, and next slot is going to starting with 2012, and finally the last slot is going to starting with 2016. So simple. So you have 5 elements, so that 20 bytes of memory is allocated, which is divided into 5 slots, and each slot is uniquely identified by an index number starting from 0 to n minus 1. So in the first slot, it means at 0th index, it will store the first value. In the second slot, it will store the second value. In the third slot, it will store the third value, and so on. Now, this identifier ARR, right, which is referring to the starting address. In this case, the starting address is 2000. Let's say you want to access an element from an array based on the index number. So you just give ARR of 0. It means you are trying to access an element at index 0. So how it will figure out? So first it is ARR. ARR is referring to 2000. So it will take that address plus you mention the index number, right? It will take that index number into 4 because each value is going to occupy 4 bytes of memory, so it will just take 4. So obviously it is going to return 2000 address. At 2000 address, what is the value is present, it will just return that value, so which is 10. Similarly, you want to access an element from index 3, same logic will apply. So starting address plus index into the data type size, which is 4, so which is going to be 2012. So at 2012 address, what is the value you have? So you have value at 2012 address, you have value 40. So that 40 will be written to us. So it means if you know the index number, finding the memory location of that index is always going to be a constant. So it's simply a math. It will identify the address, it will get the value. So that accessing the element from an array based on the index number is always going to be constant. Similarly, if you want to update, let's say I want to update. So if you want to update, so for example, I'm trying to update AR of 0 value with 15. So what it does, so based on this index number, it will identify the address, obviously, which is going to return 2000 address. Okay, so it will just return 2000 address. At 2000 address, what is the value we have? So we have value 10, so which will be replaced with 15. It will simply replace that value with 15. That's it. Even if you want to update an element based on the index number from a given array is always going to be constant. What did you understand when you mention the index number, right? It is not at all traversing to the array. It is figuring out the address based on the index number and blindly going to that address and accessing the value or updating the value. That's why if you know the index number from a given array, accessing or updating an element is always going to be constant based on index number. Now, let's say you want to delete. So if you want to delete, so let's say you have elements as 10, 20, 30, 40, and 50, and which is starting from 0, 1, 2, 3, 4 indexes. You want to delete an element. You want to delete an element from index 0. Let's say this is referred by ARR. So what is going to happen? This element is going to be removed. After removing that element, all the elements next to that index should be forwarded an index before. Otherwise, you will get a wrong result. So this is really a costly operation. So that delete operation in array is not at all allowed. So if you delete an element, all the elements next to that index should be moved one index forward, which is really expensive operation. So that delete operation is always going to take the time complexity as linear, and this is not at all allowed within an array. Similarly, if you want to search, let's say you want to search, I want to search element 5. So what you need to do, you have to traverse to the complete array. So this is your array. So if you want to search, there is no option. So you have to traverse to the complete array. And you know that in an array, each element can be accessible through an index number. So what you can do, simply a pseudo code. So you can have index starting from 0, which is less than length. So you can say length can be stored as n and I plus plus. Then what you can see, you can just take that value from the given index. So initially it is 0, then 1, 2, 3, 4. So if that value is equivalent to value 50, then you will just return true. So otherwise, at last you can return false. Right? So this is how you can simply write a iterative logic within an array. So you first you compare with index 0 value, then you compare with index 1, index 2, index 3. So when I compare with index 4 value, I see that value is equal to 50, I can return true. For example, if I given value as 75, so none of the index found this value, so that it will blindly return false. So if you want to search an element in an array, you have to traverse the complete array so that the time complexity is going to be linear. That's it. Hope you understand why array index number starting from 0 ending with n minus 1. So, and you also understand that index based operations of get and update is always going to be constant, but if you want to delete and search, it is always going to be linear. That's it for today. Thanks for your time. See you next time.